Okay, this lesson we're going to look at what the atmosphere is, and our goal is to learn different parts of the atmosphere. So hopefully by this short video you'll be able to tell me what the atmosphere is and then explain the different sections of the atmosphere. We're looking at syllabus outcomes P1, the first one, and our keywords are atmosphere, troposphere, stratosphere, thermosphere and mesosphere. What does it look like? Well, there's a really good picture of what the atmosphere looks like. It starts off from the surface of the Earth and goes to about 100 kilometers into the sky, into outer space. What you can actually see there, that haze of blue, is the ozone layer, and we're going to look at what the ozone layer is and what it does a little bit later on. So when we're talking about the atmosphere, this is the picture I want you to get into your heads when we're talking about the atmosphere. So what is the atmosphere? Well, it's a transparent, odorless mass of gases that surrounds the Earth, and it's held there by gravity. As we get closer to the surface of the Earth, gravity obviously is a lot stronger. So the further we go up from the surface, the less gravity is there. What does the atmosphere does? Well, it's a number of things really. Like the ozone is sort of like the sun cream of the Earth. It protects us from heat, particularly from the sun. And basically, without the atmosphere, there would be no life on Earth. That's why other atmospheres and other planets can't support that, and that's why there's no life on other planets. The atmosphere doesn't have any boundaries. It belongs to no one. So when we talk about pollution and the effects that humans are having on the atmosphere, that's one of the big problems. And how do we actually manage climate change and the atmosphere? That's tricky. But we'll look at that later on. The atmosphere, how was it formed? Billions and billions of years ago. What we do believe, the atmosphere wasn't there during the Big Bang. It actually was created afterwards, after there was a surface, and it was created by volcanic eruptions. Why was that? Well, because gases were trapped underneath the surface of the Earth and in the mantle, and they needed to escape. And how they did that was simply break up the surface of the Earth, and then they were released around the Earth, and because of the gravity force, they stayed there. In Earth's early history, the atmosphere was composed of 80% water vapor, 12% carbon dioxide, 7% sulfur dioxide, 1% nitrogen, and the remaining of trace elements. So it has changed considerably. Sulfur dioxide, what is that? Well, if you ever smell a fart bomb, that's what sulfur dioxide. It smells like rotten eggs, and it's used, believe it or not, as food preservatives and in the winemaking industry today. So if you look at the percentage of what the Earth's atmosphere was during Earth's early history, really different from today. What's it like today? Well, this pie chart shows you what the Earth's atmosphere is made up. The one on the left hand side, the blue, a lot of people think naturally that there's lots of oxygen in the atmosphere. It's not. It's only the second greatest amount of gas in the atmosphere. Nitrogen, there's 78%, followed by oxygen of 21%. Argon, 0.9%. You might think, what's argon? Well, it's actually used in welding. It's used to actually get rid of any oxygen. So when when we weld, we melt two pieces of metal together. There's a substance that binds the metal together. We use argon to get rid of any oxygen, because what we don't want is when we melt or join the two pieces of metal, we don't want any oxygen in there because it will rust, become brittle and break. The argon, it separates the atmosphere, and then we can join the two pieces of metal together. That 0.1%, that trace, is then what's shown in the red pie chart. So the trace gases are made up of basically carbon dioxide, neon, helium, methane, nitrous oxide and ozone. Later on I'll be explaining what ozone is and why it's so useful. So we can see there that trace gases are basically made up of carbon dioxide, but on the whole it's a very small percent of all the gases in the atmosphere. So when we're talking about climate change, the amount of carbon in the atmosphere, although we're talking about 0.1%, Any changes, although it looks small, can have big effects on the atmosphere as a whole. If we were to draw a diagram of what the atmosphere looks like, this is what we would see. On the very left hand side, we can see atmospheric pressure. As I said, the higher we go, the lower the pressure. Why is that? Well, air pressure is the amount of gravity pushing on the air. So that's basically what creates weather, high and low pressure. Basically, as we go increase in altitude, pressure decreases. There's not as we go higher, the fewer air molecules. That's why athletes train at altitude, because their bodies have to work harder and they get fitter. So at the bottom we have the troposphere, then we have the stratosphere, mesosphere and thermosphere, and you can see the altitude. The one we're really interested in is the troposphere. In between each zone is a pore. So we've got the tropopause in between the troposphere and stratosphere. In between the stratosphere and mesosphere is a stratopause. Once we get above the stratosphere, we're not too interested in the atmosphere for our purpose. We're really looking at the troposphere. That's where basically weather occurs. As we get above that, so between 50 and 20 k's, that's when we don't have so much weather. Okay. These are the different layers of the atmosphere. Like I said, troposphere, stratosphere, mesosphere and thermosphere. Troposphere is the lowest level. It's where weather occurs. You can see there that temperatures decrease with height. A lot of people think as you go up, temperatures should increase because we're closer to the sun. It's not that case. Why is that? Well, it's a lot to do with our ozone, the filter of sunlight, and like I said, air pressure is the force of gravity. But we'll come back to that later on. Then we've got the stratosphere, the mesosphere and thermosphere. Okay, thanks.